Hello. In this video, I'm going to be solving problem 39 from section 12.4 of James Stewart's calculus. And the problem reads as follows. A bicycle pedal is pushed by a foot with a 60 Newton force as shown in the figure. The shaft of the pedal is 18 centimeters long. Find the magnitude of the torque about the point P. So we have a torque problem. And you can see here's our point P. Here is the force that the foot is applying on the pedal of the bicycle. And they give us the angles between the force and the, this axis right here. So how do we start with a problem like this, right? Where do we begin? Well, first, let's remember what the torque about a point is. Let's label this torque by tau. Then by definition, tau is the cross product of the position vector with whatever force we are applying at that position vector. So here, if we draw an arrow all the way to this point here, this can be our vector r. And if we need to be careful. So here they show that the force is like pointing down onto the pedal, but we really need to think of this force as starting at this point of the pedal and still pushing down, but we just now kind of translate the vector to the tip of the position vector. Let's call this our force F. And so we need to calculate this cross product. And to do this, because we're already given the magnitudes of the vector of the position vector r, from the problem statement, we know that r is, well, here it is 18 centimeters long. So this vector is 18 centimeters long, which is 0.18 meters. And the force, the magnitude of the force, that's going to be, well, they give us that it's a 60 Newton force. So this is 60 Newtons. And what we need to do, or rather, sorry, what I was going to say is because we know these magnitudes here, and we're given a bunch of angles in our diagram, it strongly suggests to me that the way to calculate the magnitude of this torque vector is not to compute a cross product. That would be really painful, setting up the coordinate system and everything and finding components. But instead, to use the formula relating the absolute value of the torque, or rather, the formula that relates, let me erase this, the absolute value of any cross products with the absolute values of the vectors in the cross product together with the sine of the angle theta, where theta is the angle that we would have between the vectors. So here, let me make a copy of F, say. This angle theta would be this angle right here. And because we're given that this torque is just this would give us the magnitude of the torque as R F sine theta. And plugging in what we already know, this would be 60 times 0.18 Newton meters times the sine of, or I wrote that backwards, sine theta Newton meters, or if you work this out on a calculator, this is, give me a sec, I forgot the value too. There we go. This is 10.18 sine theta Newton meters. And all that remains is to figure out what this angle theta is. Well, how do we do this? Let's go back up to our diagram. And let's extend the line that's being formed by our vectors so that it extends outward. So now we've just extended this line. And you might notice that here, because this line is straight, this whole angle has to sweep out 180 degrees, right? Or actually, there's a better way to see this. So notice here that these two lines, because they intersect, their opposite angles are going to be equal to each other. So let's say I denote this by, or I'll use suggestive colors actually. Because these two lines intersect, this angle is going to equal this angle, and this angle is going to equal this angle. Now, just because this angle theta is formed by this line R and this line F, and because these two lines formed by the vectors F are perpendicular, parallel, because we're just taking this vector and just shifting it over here, we know that this blue angle here has to be theta. But we know what this angle is. Looking at the other side, we know this angle has to be the same, but this angle is just the sum of the small angle 10 degrees plus the sum of the bigger angle 70 degrees. And that tells us that theta is 80 degrees. And therefore, going down here, we can plug this in. And if you work this out on the calculator, my apologies, I forgot to calculate the sine of 80 degrees or an approximation of it, so I had to do that really quick. This angle, or the sine of this angle, is approximately 0.9840 on and on and on. And so when we calculate the product of these two, we're going to get approximately 10.636, rounding to 3 decimal places. Okay, that's all for this video. If there are any questions, please feel free to leave a comment. Otherwise, I will see you all in the next video.